you know, always fun with technology, trying to get things worked out, right? Thank you so much for joining our webinar. Just trust me, I was saying very insightful things when you couldn't hear me. My name is Dr. Eric Labar. This is my colleague, Mike Thurber. Just to give you a little bit of an introduction for myself, I was a member of NC State Institute for Advanced Analytics faculty for a long number of years before joining Elder Research. I'm currently now a director and senior scientist. Mike abducted me one day and just wouldn't let me go, so I'm here now. But Mike, I'll let you sort of introduce yourself as well.
I'm Mike Thurber. I am the lead data scientist in one of Elder Research's office, the Charlottesville office. And before that, I've had a lot of experience as an engineer and then a data scientist for 12 years before I joined Elder Research about 6 years ago. Very happy to be here and very happy for the opportunities that we get to have of seeing all kinds of different problems. And one of the common problems we see is in the space of fraud, which is about our webinar today. And I just want to say at the outset, our objective from this webinar is to describe and lay out what a total, complete, ideal fraud analytics system might look like and can look like. We recognize that every one of you on this webinar are at varying levels of sophistication and maturity with various model types. Hopefully we can describe to you what the whole system ultimately should look like and give you aspirational goals to improve your fraud analytics platform so that you can more effectively identify old types of fraud and emerging types of fraud.
Perfect. Well, let's go ahead and jump into the slides then.
All right.
Quick background on ourselves. Elder Research is not a geriatric research firm. Just want to go ahead and establish that now. We are a specialized boutique consultancy firm focused completely on data science. In fact, we've been doing this for over 20 years now, you know, back before data science was called data science, you know, all the fun of that over time. And we have been doing everything. Predictive analytics, text mining, fraud detection, you name it, we've probably done it in one way, shape, or form. But it isn't just the analysis. We help with data infrastructure on the front end and model deployment and data visualization on the back end. Essentially, we handle the entire data lifecycle from beginning to end. So if you think data, you can think Elder Research. This is actually the last webinar in a 3-part series on fraud. In fact, you can go to our website to look at the first couple of webinars if you weren't able to join us back in January or March. Now, the next series is going to be on implementing analytics from a strategy standpoint. So please join us for that upcoming series in the summer. Now, let's get on to the fun. Here is an agenda for today's webinar. We're essentially going to start with the steps towards building a holistic fraud analytics platform. Then we're going to get into some challenges, some bias considerations, and we've got to tell stories. Criminal activity that involves falsely representing information to gain an unjust advantage is defined as fraud. And boy, is it everywhere. It's one of those things. Here are some examples of fraud, but the list can go on and on and on for different ways that people falsely represent information to gain some kind of unjust advantage over other people. However, when we think of fraud, we might only think about simple cases that we hear about on TV or in the news. But trust me, there are a variety of levels of fraud. Fraud can range from a person stealing your credit card while in their parents' basement, all the way to a complicated fraud ring that consists of true professionals. Because new types and new sophisticated ways of committing fraud are constantly emerging, a holistic fraud analytics platform must be systematically nimble. In fact, there are 2 important things that all fraud solutions should be able to do. The first one is rather easy, right? Obviously, your fraud solution should be able to observe and detect known fraud cases. This is the easy part. The harder one, on the other hand, is that a good fraud solution should be able to identify new fraud patterns. And in fact, we're going to touch on both of these during today's webinar. From that standpoint, I want to take a moment to ask you all to ask yourselves this question. Where does my organization fit on this scale of fraud maturity? Maybe you're new to fraud and have nothing in place. Maybe you're in the early stages of a full fraud framework. You're what we would consider a young organization in terms of fraud. Someone may call in a tip. Internally, someone may point out something suspicious. But as the organization matures, a fraud team, especially a special investigative unit, or what we would call an SIU, will be put in place to proactively scan, search, and investigate to uncover fraud. Common sense rules and heuristics will emerge naturally from the experience of fraud investigations. And essentially, you have a rules-based framework. Now, maybe you've empowered your SIU with predictive fraud models and fraud scoring to help the investigations and really triage the entire process. Finally, you may have a fully developed fraud framework to combat existing and emerging fraud types. What we have tried to do is lay out different techniques that we feel may go along with the level of maturity that you might be with. We have laid out some different techniques for fraud detection here on the slide, ranging from simple rules to labeled fraud data, all the way to graph systems to detect fraud like we talked about in the second webinar of this series. Here are some of our thoughts on where organizations of different maturities in their fraud framework would be in terms of the techniques that they use. I'll give you a few seconds to digest this information. However, remember, these slides are also available after the webinar. All right, hopefully you've gotten a chance to take a look at that slide here for a moment. Over time, you will collect transactions, events, or cases that need to be scanned for fraud by your special investigative unit. However, even if you investigate these cases and find some fraud, and hopefully some that aren't fraud, this is typically only a small fraction of total observations that exist out there. What about all those cases that aren't investigated? Are they not fraud? We can't really confirm if they're fraud or not because we actually haven't investigated them. So how do you actually know if they're not fraud? We're going to deal with all of these issues here in this webinar. And in fact, with all of this as an introduction, I'm going to hand it over to Mike to talk about how to move along the fraud maturity scale to developing a holistic fraud platform. Mike?
Hey, thank you, Eric. That's very good. A very good introduction. So we'll talk about the various models that are in a holistic fraud platform. In the beginning, there are models that everyone can use. Even if you have no labeled fraud data, you can build an anomaly model to detect which cases are anomalous. The caution about this is anomalous is not synonymous with fraud. In other words, somebody might look different, but they're perfectly okay. So the investigations that are conducted based on an anomaly score need to be investigated conservatively because you're not very sure at all that it's actually fraud. But it's a good start. And this kind of a model, an anomaly detection model, across all of your cases would be refreshed over and over again until you begin to acquire labeled cases where you have investigated, you know which ones weren't fraud, which ones were fraud among those that you investigated, and then you can proceed to the next step, which is a fraud likelihood supervised model. And after you've done that, then there will be, in the next stage of maturity, you're going to build a not fraud model, which sounds a lot like the one above it, but it isn't. And I will be explaining that later on. And finally, after you've figured out which ones don't look good, you may be looking at the clusters of the ones that you've identified don't look good, and we will talk about that as the final top model for a holistic fraud analytics system. So first, the anomaly models for everyone. In other words, for all of your cases. Here it is. Who is anomalous? You know, when we talk anomalies here, it isn't just identifying, okay, we've had some that we know are bad and some that we know are good. Who doesn't look right in this? And clearly, we can see somebody who's faking it. And of course, this is exactly what fraudsters try to do, right? They try to look like everybody else, but they can't quite do it perfectly. And that's what your models need to find. So, the anomaly models for all cases generally it starts with consulting subject matter experts, perhaps somebody who is on the investigations team, to build a set of features and attributes that could be indicative of fraud. And using those attributes, not just all the attributes that are available about your cases, but the ones that the investigation unit or the SMEs say are important, you build unsupervised models with them. And you can do all kinds of unsupervised models. I've listed about 4 here. Clustering, CAID, isolation forest, and semi-supervised. I'm going to concentrate on CAID a little bit more in this webinar, and we'll describe what that is. After you've done those unsupervised models, you apply the models to all of your cases, all of your current cases that you're interested in. And then, of course, that will give you a score of which ones are the most anomalous vis-a-vis your fraud attributes. And you will, of course, investigate those ones that are most anomalous. After you've investigated, step 5 is really an important one. It's a single word report. That means record in the database what the result of that investigation unit was. If you found out that there was fraud, then that needs to be labeled as fraud in your analytic data store so that you can go to the next step. To develop a fraud likelihood supervised model. So, to distinguish fraud from not fraud, in other words, ones that have been confirmed to be fraudulent versus those that are confirmed to be good, you can build that model simply. And that model will tell you who to investigate first among those that the investigation unit is given to investigate, if they're given the same kind of cases that they were given previously. But what it doesn't do, and this is subtle but important, is it does not indicate who to investigate. In other words, who do you send to the investigation unit to investigate? In order to do that better and still be in the supervised space, we do a harder process. We have an extra data preparation step here. It must be built on all cases that are representative of, it must be built on a set of labeled cases that are representative of all the cases that you're interested in. The problem here is selection bias. The ones that were sent to investigations are not a representative sample, and you need to do something to change that, and we will talk about that. If you're successful in doing that, then your model, your supervised model, will apply to both investigated and uninvestigated cases. But that's as far as it goes. It isn't designed to detect new emerging fraud that you've never been able to see before. But it will tell you what cases look like past instances of fraud. So, most fraud models do these things. Most fraud models tend to be that first case of a simple supervised model on the cases that were investigated. But they should handle the selection bias so that they can be applied and help direct all of the cases that should be investigated. You don't want to build only on investigated cases, and so we must weight back That's an important word. Weight back to the whole population properly. And we can get into that more if there's questions about how to do that, but it's a bootstrapping technique that we use so that we oversample the ones that typically don't get investigated and undersample those that are more commonly investigated. Then, after you've done that with that bootstrap sample, we build a fraud likelihood model. And that model will give scores to help know which cases need to be investigated for fraud, and it should be overlaid with an explanation of each and every one of those scores to tell you why this particular case was recommended to be investigated. And then, of course, you investigate them. And then, of course, you don't forget the last step. The results of that investigation must be recorded in your analytic data store so you can get better over time. Okay, so that is a supervised model that you certainly should build if you do have labeled cases. Now let's talk about how you go from there, because remember the limitation of these supervised models was that they do not detect emerging new types of fraud. So let's talk about how to get there. We built what we call a not fraud model. And so going back to the graphic that you've already seen before, we built a supervised model on the two different things, the contrast between confirmed not fraud and confirmed fraud in the blue ellipse that you see on this slide. But what we're going to focus on next is this item 1. We want to model cases which do not look like the confirmed not fraud. In other words, we're going to just take that one set all by itself, and we're going to build a model that says what those look like, and then we'll apply that model to the rest to see which ones do not look like the confirmed not fraud. So we will test that model. After we've built it, we'll go to that second data set of the confirmed fraud, and those should not look like the confirmed fraud. We will be able to see that with that model. My experience with this is this particular model works surprisingly well at that, and I will show you an example here in a moment. After you've tested that model and made sure, yeah, it is doing what we expect it to do, then it can be applied to the remaining uninvestigated cases, the ones that were never recommended to be investigated. And it should be applied there, so the rest of them are scored with that model. So here's an example. Now, with 3 dimensions, I can only do 3 features at once, but these 3 features were important in the fraud model. So we had a whole bunch of cases in this 3-dimensional space, and we knew which ones were labeled as bad and which ones were labeled as good. The blue were good and the red were bad, and it was almost a perfect model, which isn't always the case, but sometimes you really do quite well. And so it could easily distinguish, and as it turned out with these 3 variables, it could easily distinguish between the bads and the goods. That's their simple, straightforward, supervised model. Now we took just the blues, and we applied a process named CADE, which takes those blues as they are and labels them as zeros. These are goods. And then it shuffles that data to create synthetic records that are not real, but they have the same range of values in them. And then you build a supervised model on that difference between the real records and the not real records, the synthetic records. And then you apply that to the whole set. And what you see on the right is the result of that application to the whole set. The reds are the ones that were labeled by both models, the supervised and unsupervised CADE model, the same. And so are the blues. They gave you the same answer. But if you look carefully, and I apologize, you can't see all the yellows, but you'll see some of those blues turn to yellow dots. Those are cases where, okay, they were never labeled as fraud, but they don't look good. That's the key point, is they don't look good, and therefore they may be an emerging fraud type. A really critical point here. So, you've built that unsupervised model, and you have all your cases. You're looking, you apply that unsupervised model to the rest of your cases, and you'll divide that then into those that get a bad score. They don't look good. And then you take that set and you apply clustering to it, which is your last kind of model. And you'll see that there are patterns among those that don't look good. And now you can look at each of those clusters and discuss them with your special investigation unit and decide which ones you're actually going to pursue. Further, if there are other not good cases that don't belong to any of those clusters, in other words, they're far removed, but they're still not good, those are another set that may deserve investigation, especially if they are high-value cases. Okay? So, this is what we do. This is sort of your recipe slide. I don't think I'm going to read the whole thing here, but this is kind of a recipe slide of how this gets done with this clusters of not good. You apply the non-fraud model to the uninvestigated cases, you take the most likely cases, and you use the same inputs for your clustering model that were used previously, and you build a k-means clustering score or set to these, and then you study those clusters with a subject matter expert, as I said before. You investigate the most suspicious clusters, and you investigate the most anomalous cases. In other words, the bads that aren't in any of those clusters. And then, after your investigation, again, you must record the result in order to be a continuously learning fraud detection organization. You need that recorded in your analytic data store, so upon model refresh, you can get better each iteration. Okay, so there are many alternatives to unsupervised approaches. I've described CADE to you, and there's more detail in the printed slides that you have access to about that. But there's another technique called isolation forest, which is an unsupervised technique that says how easily is each case isolated based on all the variables that were given. It's extremely powerful and a very good way of doing it. Again, anomalous doesn't mean fraudulent. The semi-supervised techniques are very effective, especially for rare events, for terror attacks where you have only one or two cases, but what you're looking for is for those one or two cases, do they belong to a particular pattern among all the cases? And that graphic on the right, the swirly pattern, you have these patterns that kind of interweave, but yet there are still distinct patterns, those lines in the top and bottom graphic, that tie them all together. That's a semi-supervised technique. And of course, there's whole courses on how those semi-supervised techniques work. A network relationship features. Let's not forget about that. We've already had a webinar on graph databases, and this builds on that. It doesn't in any way diminish from it. The fact is that graph features are extraordinarily powerful in fraud models. And because the fraudster leaves so little data behind, the network data becomes even more important for those who are trying to look like penguins when they're really cats, as you saw previously. Okay, so let's summarize a little bit here. The purely unsupervised technique alone, the pro for that is it doesn't require any labels at all, no fraud information at all. And it will find emerging fraud, but it also finds a lot of, no, these don't look like the rest, but they're still good. So there's relatively poor accuracy, and it's a rather naive model. Supervised alone, on the other hand, is highly efficient and defensible. You're going to get a very good hit rate on the cases that score highly from your supervised model, and you'll just get really good at detecting patterns that you already know about. And the con, of course, is that it misses the emerging new fraud paradigms. So the third one is the sequential supervised first, and then the unsupervised that I've described just before this. It fully leverages everything you learn from the supervised model, and it gets all the benefits of that, but it also gives you the emerging patterns. The cons is, okay, this is the most advanced. This requires the most work, but it is the way for you to be a completely holistic fraud platform to support your investigations. Okay, and so from that, I will turn it back over to Eric, who will discuss some cases, some actual examples that we have worked with.
Perfect. Thank you, Mike. And don't think you're getting out of this. You're helping me with this case study now. This isn't just me.
Okay, I'll try.
So next, we're going to talk about a case study around fraud, really just as we have done throughout this webinar series. So although we may only talk about 1 or 2 case studies here today, I don't want you to think that those are the only case studies that we have. So just as a reminder, in the previous webinar, we talked about 3 different investigative organizations and other industries around fraud, other than the one we're going to talk about here. So if you're interested in other case studies, please go back and watch those just to get some different examples on how to be able to apply some of the fraud techniques that Mike and I are talking about here in this webinar to different kinds of industries and different sets of data. So let's jump in here a little bit though. So essentially, the problem here is to figure out which providers might be abusing the system. And here, we're talking more in the realm of pharmacy fraud, but you can imagine this in a variety of different ways, right? Whether it be any kind of medical fraud, whether it be insurance fraud. Here, we're focusing in on pharmacies. But still, the main question is, which providers may be abusing the system? As well as also trying to cluster some of these services together to try and figure out better ways to look at the data. Now, the data that was available was transactional data, and transactional data, and Mike, tell me your thoughts on it as well. I think transactional data is probably the richest kind of data, and I always love it. I'd rather have more data than less data in these kinds of situations.
This is true. We're all data scientists here, and we love detail. And but we want that detail to connect. So I would argue that with the transactional data, you want to be able to do, okay, this person was served by this agent. That agent also served these other 6 people, because if we see something with a fraudulent agent, just taking an example, we want to see everybody that they served, even when the transaction all by itself looks perfectly fine.
Exactly. And I think that's the beauty of the technology, and really the world we live in today is the availability of transactional data. So we had transactional data available. The biggest thing I would highly recommend for any kind of fraud problem is to try and deal with the data at a transaction level. Now, the data that was involved in these transactions was payments to providers for each service, essentially each prescription, for each one of the patients, with limited features for services, patients, and providers. So we've also added in graph features, basically similarity of providers by services. So we have this idea, much like what Mike was describing, where we have individual transactions, but these people are tied together in ways that maybe an individual transaction database might not be able to show. And so if that's the case, how can we use, again, going back to our second webinar, how can we use graphs to be able to tie people together in a way that maybe people would not have thought of before? So again, we're looking at similarity of providers by services. We're trying to do provider communities by patients. So just to give you a little bit more insight, there are certain providers that share patients, which would make sense. And then pharmacy provider patient type networks. We need to find these networks of individuals together. To go into a little bit more detail, again, we try to apply this in a graph database kind of scenario. Really viewing the problem as a graph and investigating, these insider threats, as you might call them. collusion, kickbacks, things along those lines. One way to potentially look at a problem like this, and it's one way that we did look at this problem, is if you have a large amount of overlapping patients, that's probably not something that we would expect between many different providers. Now, obviously, you know, and Mike and I were actually talking before the webinar, it's something where people in the same family might go to the same provider. You know, my wife, my kids, they all see the same doctor that I see. It makes sense for there to be some kind of overlap and some kind of connections. Or if there's a large population with a small subset of providers, again, overlap is expected. But maybe too much overlap might be a sign of a little bit of anomalous situation. And so that's really what we're looking at here. So as an example, to be able to do this, the Jaccard index is one way to be able to look at this overlap. Again, what you see in the Venn diagram here on the slide, the first provider treated 500 patients. We'll call that provider A. Provider B treated 400 patients. Now, of these patients, 350 of them were actually served by both provider A and provider B. So we have that intersection, that union really of the two sets, but we're looking more on the middle where they share. So that's really what we want to take a look at, is the Jaccard index, or really some notion of a measure of proportion. With the higher the Jaccard index being, the more overlap that there is. The smaller the Jaccard index, the less overlap. And Mike, I'm actually going to hand it over to you because I believe you are the author of one of these amazing charts, so I'm going to let you sort of explain this a little bit more.
Okay, so we have a graphic on the left here that is about, I think it's on the order of 219 providers. If you look at the first provider in the upper left-hand corner, or the second provider, one of those dots is the intersection between the first and second provider. And now the providers are sorted the same way along the vertical axis as they are on the horizontal axis. And the color that you see in this graphic for each of those pixels, if you will, is the size of the Jaccard index. If it's 0, then the pixel will be white. If it's 100%, then it will be solid blue. And these providers are sorted with a hierarchical clustering technique, a common clustering technique. Let's move to the next slide, and then I'm going to come back to this slide. Hierarchical clustering, I can't even say it right, hierarchical clustering does in fact sort all your cases with a cluster dendrogram here. And let's go back. The providers are sorted, therefore, along the horizontal and the vertical axis via that clustering technique. And now when you display this, we see very interesting information. We see that some providers there's 2 boxes in the upper left-hand corner, clearly distinctly different providers serving distinctly different populations. But in the remainder of it, you see another large box which has some subclusters in it. And that's the nice thing about this graphic, is you visually see the potential clusters. Some are more starkly differentiated than others. And if there's a network of providers that are working together in a fraudulent way, they will be in the same cluster.
Along those lines, Mike, a question that actually came in. How would you account for the differences potentially in urban versus rural areas with the Jaccard index? That notion that maybe you just have a lot of doctors and or a lot of people surrounded by a few doctors to be able to try and balance all of this out?
Yes, indeed. That's a really good question, because in fact, this is, I won't tell you a lot about it, but it's 3 different counties worth of data. I assure you, though, that these 3 major clusters that you see most starkly visually here are not 3 different counties. They are, in fact, providers who are seeing different types of patients, perhaps a different age group or different insurance completely. So, so this is useful for both. This isn't telling you necessarily that each of these clusters is fraudulent. It's simply telling you that the providers in that cluster are tightly linked. And if you find out that one or a large proportion of them are fraudulent, then you really need to look at the entire cluster of providers. That's what this is telling you.
I think that's a great point, Mike, because I think one of the the aspects of this is just an extra piece of information that we're building into the entire system, right?
Yes.
Where really, you're exactly right. This is not necessarily indicative of fraud itself. It really is just an extra factor, where this, as well as other factors that might be going into a holistic fraud model, might be saying, wow, you know what? One of the doctors or one of the providers in the upper left-hand cluster might have, because of a variety of other things as well, fraud. And so now we've investigated them, we feel that there's fraud. This actually opens up the window to who else should I investigate? Most likely people who are probably working with them. Exactly.
In that cluster, yes, that's well put.
Perfect. Awesome.
So we talked about this already. This is the way we sort those so that graphic looks so beautiful.
Exactly. The fun part, right, is having graphics make other graphics more beautiful. It's always a great way of being able to
There
pull
we
this
go.
off.
We love it. We're data scientists.
Exactly. Exactly. Perfect. Well, I want to make sure we can put this all together here at the end. We'll be getting to questions here in a few minutes. But the final summary, really, of the holistic fraud analytics platform is really laid out here. This is sort of an overall recipe chart, if you will. It's something where when you come back to download these slides later, and I know you will, this is the one I would go to first, in all honesty, because this sort of lays out, again, the whole idea. The notion of curating the data, making sure we have the data from both internal and external sources provided correctly. Gathering samples from different times, different places, looking at entity resolution. We didn't really talk too much about entity resolution here. We didn't have time. But again, the idea of entity resolution is making sure we can identify observations correctly. Adding in relationships and graph features as best as we can. Removing bias, like you had talked about previously, Mike. Building this supervised fraud model. Building and deploying the not fraud model. I always love the names of those models. And
Sorry about that, but that's what we need to do in order to find the emerging fraud.
It's true. It's true. Two negatives doesn't imply a positive here. That's definitely the case.
That's what's happening.
And so then refreshing all of this periodically as well to make sure that the things are always looking, right? Fraud models, I think the best part about them is that really it ensures our jobs for a long time, because it's something that you have to constantly look at. Fraud always changes. And because fraud always changes, this is not something we can put in place and sort of leave forever. It's something we always have to be able to make sure we understand things.
Yeah.
So, perfect.
So I see a question up here, which I'm going to actually read out loud for everybody. How different do the variations in fraud among providers need to be in order to distinguish them? If every provider is committing a similar level of fraud, does that make it more difficult to distinguish? I would say it depends. As Eric was saying, you look at other factors besides just that Jacquard index, and by the way, there are a lot of other kinds of graph features that you can develop as well, and it's really the collection of those things together that help you know what to do. And of course, you use supervised models. I hope that's clear. I hope this point is clear. These graph features that we develop are simply in addition to the other features that you're already using. They don't replace them. They add to, and you use them together, and over time you develop more and more information as you go ahead and investigate those cases, and then you say, okay, in this cluster of providers, there are 12 providers, and 4 of them have shown fraudulent transactions. Well, then we focus more on that whole cluster of providers and look more deeply at the other scores. Even though they were relatively low, the fact that they're part of that provider network is really important. So I hope that begins to answer the question.
Perfect. Now, again, there are many other things to consider in this whole process, but in only a 1-hour webinar, there's only so much we can actually talk about, right? And so with that being the case, other things to think about and consider, again, we briefly mentioned the words entity resolution. We didn't go into detail about them here. Graph features, we've had an entire webinar really on, how to try and introduce incorporating networks into a frauds framework. Again, it's not completely there, but graph features should always be taken care of. Third-party data sources obviously can help with the whole process. And again, many other things to consider as we go along.
Let me just talk, Eric, a little bit about this entity resolution.
Sure.
I don't even think we have slides on this, but it's important. This is actually the hard work. Especially when you're doing graph features, when you're trying to say which providers are linked. Well, and it isn't just providers. We're talking about, we keep on using that example, but it could be marketing, it could be any industry that you're talking about. If there's a network of people, that network, who are professional fraudsters potentially, are very good at obfuscating their identities. But they have to leave some clues. They use the same IP address over and over again, for example. They may use the same, okay, if it's automotive insurance, they may be using the same body shops over and over again. And doing that entity resolution is truly an art, and it's not something you can easily just buy off the shelf, because depending on your use case, the what you call it, the false negatives versus false positives on your matching have different costs. And so it almost needs to be custom built for the fraud problem that you're facing.
Awesome. Another question that came in, which I think we both might even have some opinions on, really, are sort of what languages we might use for building these fraud detection kinds of models. I'm personally more leaning towards an open source. That's sort of what my background more is. It's something where in R and Python, being able to code up some of these models, I don't think is overly complicated. There are some things that are already pre-laid out. For example, some of the clustering algorithms and stuff that we showed earlier in the dendrogram that we could be able to provide. But, that's where I sort of lean on these things. Mike, what's sort of your opinion on it?
Yes. So I have a little bit of an agnostic opinion here. So I apologize for that. The important thing is the process that you use, and it matters a lot less which tool. So I've used SAS before. I've used SPSS or the IBM Modeler as off-the-shelf tools, but the open source tools are very valuable, and as everybody knows, they have algorithms in them that are the newest and greatest, and so frankly, we use them all. We use whatever is handy at the client side, since we are a data consultancy. So we're very nimble with the various different tools. But there are a lot of emerging things. For example, if you look up isolation for us, there's a really good Python package that does that. If you're not familiar with isolation for us, you should become familiar, because that is an outstanding unsupervised technique.
Perfect. Along the lines, Mike, I want to go back a little bit to sort of what you were talking about earlier in your section when it came to the idea of selection bias and making sure that we represent the whole population, because the investigated cases themselves are a small sample of what we actually look at. And so I imagine even fraud itself is a very, very small sample compared to the whole population, hopefully, otherwise the company probably wouldn't be in existence anymore. And so that being the case, can you explain in a little bit more detail what you mean by sort of trying to make sure that we can sort of get the model back to the overall population?
Yes, I appreciate that question, Eric. And this is kind of a little bit of secret sauce, I would say. Actually, it isn't that secret, because the process, the technique was invented many decades ago. But what you do is you do a propensity to be investigated model. That's completely different from any of the other model types that we've mentioned today. But you do, the question isn't whether it's fraudulent or not. The question is, on your past historical cases, build me a model that says whether or not that person is sent to investigations, period. That model the score from that model should be a probability of that case to be sent to investigations, given the historical way that was done. And now you have that's historical way it was done, and now you also have your historical ways or cases that were actually investigated, where they're ones or zeros, and you apply that score to each of the investigated cases. Most of them will score high, because guess what? They were investigated. But some of them, by chance, may score low. Those are the ones that need to be what can I say, bootstrapped at a higher weight.
Mhm.
And so we use a weighted bootstrapping technique to finish that process of getting a sample that is truly representative of the whole, but is all labeled. I hope that helps.
Yeah, and so along those lines, I think that, you know, that kind of sampling technique is sort of one way of being able to try and handle this idea of making the population look as the whole, you know, which is the big thing when it comes to rare event situations, right? When it comes to fraud. It's the same thing. We see it all the time when it comes to credit scoring and things along those lines, when we run into, you know, small samples of people that actually default on loans. Same thing for here, small samples of people that actually commit fraud. Sampling is a classic way of being able to try and, you know, and weighting back to a population is a classic way of trying to be able to handle this rare event kind of problem.
Absolutely.
Any kind of other techniques you can think of outside of sampling to try and get back to this idea of what the whole thing looks like from a population standpoint? That's what I typically would go to and recommend. I didn't know if you had seen anything else over the years.
Yeah. So I guess I want to stick with that, though. The sampling is so terribly important.
Mm-hmm.
It's the biggest mistake that is made in almost all of data science, is this sampling problem, that you need to be building your model on a sample that is, listen to me, representative of the population that you want to score. If I could just embed one thought for all of data science, that is it. You want to make the sample that you build your model be representative of the population that you want to score. And then further, we haven't even mentioned the word testing once, have we?
No.
And all this thing. We, Elder Research, are huge on testing.
Mm-hmm.
And the testing strategy. Furthermore, you want to test in a way that is representative of how your model will be used. Well, what does that mean? It means your model is always being used on, guess what? Brand new cases. So you want to train models as you're trying to figure out the best possible model on a sample that is distinct in time, in other words, future from, and is a completely different set of individuals than were used to build your model. And of course, you do that repeatedly in a cross-validation scheme. We could have a whole seminar on that, and I'm sure we will, on exactly how that all comes together. But the proper data science techniques of building a model are extremely important throughout all of this.
And so in that idea of testing, Mike, when it comes to the notion of like measures that we use, I know, for example, the things I like to go to, especially in these kind of classification kinds of problems, when it comes to measuring, you know, these ideas of testing or validation data sets, I like things like precision recall, F measure, stuff along those lines, as sort of a balance between those false positives and those false negatives, which I think is an important point to make mention of. A false positive and a false negative may not actually have the same weight in a fraud problem. You know, how much of a problem is it if I miss and accidentally think someone is fraud but they aren't, compared to miss in the way that someone actually is fraudulent but I didn't. You know, I think those definitely have some different costs to them. So whenever we think about this idea of testing and validation and try and balance out the notion of precision recall, F measures, we really need to think about it in that sense as well, that we're not just trying to be necessarily quote unquote as accurate as possible. It's really more we're trying to be as accurate as possible given a unbalanced cost measure that may be going on in this whole process.
Yes. So that whole idea of setting a threshold score where above this threshold you investigate it, below you do not, the way that is decided upon, is exactly what Eric was talking about, the relative cost of a false negative versus a false positive.
Very much so. Very much so. Let's see here. We've had another question that's come in. How does a bivariate probit approach compare with the bootstrapping technique you just outlined for the sampling challenges?
I'd say they go together, don't they?
Yeah, I was going to say, I think they work really in conjunction with each other in that regard.
They are not mutually exclusive at all. One is your sampling technique for your model build, and so.
Yeah, I was going to say the sampling is always outside of the modeling, I believe.
Yeah.
Definitely. Definitely.
So a bivariate probit approach is perfectly fine. Yeah, we're good on that.
Yep. Any any other questions that might be out there for us to be able to answer? We'd be happy to be able to answer anything you guys might have. In fact, let's throw up the question and answer slide. That might entice some people to throw some question and answer. There have been questions that have been coming in before we even asked, which is perfect. So now we get a chance to be able to do that. As people are potentially writing some more questions for us, one thing I did want to make sure of is that this webinar will be archived and available. Next week, the recording will be available on our website. That screen will also have a link to download the slides as well. So it's something where, as we've mentioned, to go back and look at previous webinars, you can actually go back and look at this webinar as well as the slides starting next week. They'll be on our website. If you need them sooner, Paul's email, which was at the very beginning, and I believe we'll show it here again at the end, will be able to help you with that as well. He's our director of marketing if you need to look him up on our website.
Okay. Eric, I just remembered that there's another point that I wanted to make that I don't think I really put in the slides. And that is, in any kind of these data science problems, any data science problem, there's some parts of the problem that may be obvious. And when we've described the holistic platform today, you know, things can be obvious on about certain types of fraud. If you know that if X and Y are true and the data says clearly X and Y, you just simply know they're fraud, then of course you always send them to investigations to, of course, catch the fraudster and put them in handcuffs, whatever you need to do. But don't let machine learning try to solve that problem for you. In other words, take out what you already know as a fact. And for example, if we did that final unsupervised model of not goods on the whole thing, in other words, the cases where we knew that there were some bads in there, the model would be far less powerful. The fact that we already took out what we already knew and only did the unsupervised model on what we didn't know is a really key point philosophically for fraud modeling. Of course, this applies to any data science problem, that you strip away that which is obvious and then let the machine learning do the hard work.
Gotcha. No, definitely agree. Definitely agree. Another question that's come in is really the speed of which this analysis is done. Is this analysis continuously running with the addition of data, or is it more of a one-time run every hour or day? I think that really, how about this? In my opinion, and Mike, let me know yours as well, obviously. I think the breadth of the analysis that we've described is maybe not necessarily an analysis that is constantly running. The models to score people, I believe, can basically be run as constantly as data can come in. Yeah. But it's not necessarily something where you would do the unsupervised approach and everything like that live as things go on, because again, it takes some expertise, some subject matter experts to be able to come in, look at the big clusters that we've identified to try and find some of those rare cases going forward. So I sort of see it as a little bit of a balance. The model itself can run as quickly as the data can come in, but really the holistic fraud framework that we've laid out is more of a process that would take time to be able to continuously look at.
Yeah, you don't want to be spending all your days building models. You want to be, in fact, my experience with model builds over the last 20 years has been that we spend more time supervising models. Excuse me, I probably used the wrong term there, where we're continuously monitoring the performance of the model. But it's a very different thing to build a model than it is to score people in deployment phase. Having said that, we could point out that some of the features that are available in real time, or some of the features that we would like in our fraud model, might not yet be available with your IT infrastructure to do real time, and so you have to limit yourself to what you can get on a real-time basis, depending on your use case. If you're doing credit card fraud, it's different than if you're doing insurance claims fraud.
Now, Mike, for the case study, I apologize greatly. I don't remember how many rows we really had in that, how big the database was in terms of claims and transactions. Do you happen to remember off the top of your head?
The one with the blue chart?
Yes, yes.
Yeah, that was about 219 providers, but something on the order of 50,000. No, more than 50,000, probably on the order of 100,000 services performed.
And that's just in the actual services. So does that actually count as all of the transactions as well? So the 100,000 transactions or more 100,000?
In this case, the services were transactions.
Perfect. Excellent. Excellent.
Yes.
Another question that's come in is really the idea of simulation to be able to potentially sort of boost the amount of data that you might have. In the case where you may not have a lot of data, both fraud and non-fraud, can simulation somehow help in being able to sort of enhance the data set? And it kind of is back to the idea of bootstrapping that we've talked about a little bit.
Yeah, and it's also back to this CADE technique where we simulate artificial cases where the relationship among the columns is completely disturbed. It's shuffled. It's completely disturbed, and yet it is a simulation of what could possibly be. And so now I recognize there's a ton of different kinds of simulation techniques that you can do. The simple answer is yes, but I'm sure you would you'd like to see lots of different examples there.
Definitely so. Definitely so. Any other questions that are out there that we may have missed in this process? So as people are coming up with other questions, just sort of as a refresher to those who may not have been able to be here for the very first couple of slides that we talked about, it was just a very brief introduction to sort of our company and what we've done. Again, we are Elder Research. We've been around for 20 plus years, servicing over 150 different clients in the world of data science. Really trying to be able to help people understand their entire data life cycle, everything from the beginning of data all the way to the end of data. And so it's not just fraud that we focus in on and specify. It really is anything involving data and analysis. It could be text mining, which we've done lots of, credit scoring. I know, for example, we've worked on marketing analytics to try and help validate some of the marketing techniques that people have taken on, supply chain analysis. We do have an office that works with government work as well. I'm not allowed to mention some of the things they do there. So we have all of those different aspects to all of this.
Hey, Eric, I even told them that I used to be an engineer. And guess what? I was a chemical engineer, at least that was my background. And I didn't think I'd ever touch chemical engineering again until a few months ago where we were, guess what? Optimizing a chemical process. And we were using data science to get it done. And boy, was that ever fun. It was just a thrill for me to do that, to do a completely different way of doing engineering. I see a question here that needs to be answered. The different scores from different models. So very, very good point here. As we indicated, especially in the unsupervised case, you can have lots of different kinds of anomalies. An isolation forest will deliver different anomalies than a cluster algorithm will. And you can use all of those. So in order to do this webinar, we've done it in a simplistic way. The point is well taken that you may have multiple scores and those scores work together. And only experience will tell you how they interact and how to best use them with your special investigation unit.
Perfect. So unfortunately, we won't be able to get to necessarily all the questions that are out there, but you have our emails here. So please, if we didn't get a chance to get to your question, feel free to reach out to either Mike or myself. We'd be happy to be able to help you with that. It's one of those things, I think, as a final thought to just this webinar series, and really even a prelude to the next webinar series. We've talked a lot about fraud over the last 3 webinars, but we have a ton of experience in analytics. And I think that has really informed us on all the roadblocks that we've seen along the way in solving these kind of problems, to be able to help organizations overall not have to go through some of these same roadblocks, right? So, from not only just an analytics standpoint, but a strategy standpoint around analytics, who better than the analysts who have been doing this for the last 20 years to be able to help us out with those kinds of problems? So again, thank you all very, very much for the whole thing. We look forward to being able to see you at our next webinar.
Thank you very much, Eric. I appreciate it.